Chapter 12, Section 5. Comparing volumes of prisms to volumes of pyramids over here. Look closely at the colors in that right diagram. They have taken a prism and they have divided it up into pyramids. There's an orange one, there's a yellow one, there is a green one, and it exactly as a total is the same shape as this prism on the left. How many pyramids came out of that prism? 3. Exactly 3. The orange one, the yellow one, the green one. The volume of a pyramid compared to a prism of exactly the same height and exactly the same base is going to be what fraction of that prism? 1/3. Because there are exactly 3 of these that could fit into one of these right over here. Exactly 1/3. And there is our formula. The volume of a pyramid is exactly 1/3 the area of the base times height. So when you already know the prism one, you really already know the pyramid one. Just remember 1/3 in front of it. That'd be the next thing I'd write down on your notes of all these equations we're going to have to know right here. So 1/3 area of base times height. So if I am going to find the volume of this pyramid over here, I know it's 1/3 the area of the base times the height. And finding our base is going to be doing what? How will I find the base of this thing? Length times width. 9.5 times 8. See if you can warm up your calculators for me and we can quickly get some of these answers. The height is 9 centimeters. So if I was doing this, what's 1/3 of 9? 3. I'd go 9.5 times 8 times 3. Then I don't have to mess with 1/3. How much? 220? 228 centimeters cubed? Thank you. Centimeters cubed. So today's section should be pretty straightforward for us. What kind of curveballs will they possibly throw? 1/3 area of base times height. Well, how am I going to get the area of the base of this thing? Are you kidding me? 22 centimeters. Let me rephrase that question. If they didn't tell us the area of the base, what would we need to do?
Get the
1/2 apothem times perimeter. We'd have to figure the area of that hexagon down there. 1/2 apothem times perimeter. Well, base is 22 square centimeters, height is 5 over here. So what do you get on this? And it'll be approximately 36 and 2/3?
Yes.
That would be the exact. 36 and 2/3 centimeters cubed.
Could you put the decimal?
36.7 if you rounded to the nearest 10 centimeters cubed. Cones. What do you think it's going to be for the volume? 1/3 pi r squared times the height. Exactly the same thing. So this leads me to, sometimes you have these water bottles, water fountains, but they've got a water bottle on the top and they have these little cups sitting off to the side, these paper cups that you pull down. They're usually this shape, right? Very rarely do you have one like this. So sometimes you'll get some that are, kind of like this. So when they give you this nice little cone out here, how much water do you get in it compared to if they would have had this cup? Just 1/3. Just 1/3 as much as sitting right over here. So these things are nice and cool and nifty, but they don't hold much water. You probably experienced that. If you were thirsty, you put it in and you drink, and it's like, oh, my mouth got wet. You put it in and you drink. 1/3, not very much volume in those cones. So same idea, it's just 1/3 the volume. Volume of this cone is 1/3 pi r squared times height. So 1/3 times pi times, what's our radius? 3.2, which we have to square. What's our height? 5.8. Run that through your alternate brain. 62.2. Everybody else getting the same thing?
Yeah.
Meters cubed. Find the volume of this cone. So, what's the big deal? It's this volume is 1/3 pi r squared times height. So we'll start filling the stuff in. 1/3 times pi times, what's our radius?
Don't know.
Oh, how are we going to get the radius?
Tangent.
We're going to use trig functions. Are we going to use tangent? Well, that angle tangent is opposite over adjacent. Sure enough, we know that the tangent of 58 degrees should equal the opposite, 11, divided by the adjacent, which is our radius. So if I multiplied by the radius to get rid of that fraction, and then divided by the tangent, help me out to, let's go to 3 decimal places. 6.873? 4?
Yeah, it's 11 divided by 10. Not 10 divided by 11.
It is. 2 in the world are at that. 11 divided by the tangent of 58. Good thing you guys did it correctly. 6.874. Just leave it in your calculators even better. I'm going to write it up here, 6.874, but just take your answer, multiply by pi, and divide by 3. Or multiply by 1/3. They're both the same math operation. Nearest 10. How much?
You need to multiply by 11 too. And square. Yeah.
Wow. Who is the teacher today? You better square that radius. So you might have to go back.
544.
544 to the nearest 10? 0.3? Did you get 544.3?
Well, it's 544. I got 544.
544.3.
0.3? I got 15. Yeah.
0.3 or not? I don't know.
Yeah.
All right. 0.3 inches cubed. There we go. So what's down here? A pyramidion. That was discovered in Saqqara, Egypt in 1992, has a rectangular base. A little hard to see the picture here. You can see it in your book. 53 by 37. It's 46 centimeters high. So what is the volume of this pyramidion? Round to the nearest 10.
We don't have to.
What's that? You don't have it in your book?
No,
That's the picture. Volume is 1/3 area of base times height. So 1/3, how are we going to get the area of the base of this thing?
Length times width.
53 times 37, length times width. It's rectangular. Rectangular base. And 46 centimeters high. 46 right out there. Nearest 10th. Volume.
30,068.7.
30,068.7? Anybody else getting that same thing? All right. There's our volume. So that's the idea right here. It's comparing, if you remember those old formulas for the prism and the cylinder, then you've got the new formulas. 1/3 area of base times height. 1/3 pi r squared times height. Let's go to the book. That was quick and easy. So I wonder what the homework will be like. Page 876.
Hard and difficult to do. Our usual geometry class.
Page 876. Number 1. Directions say to find the volume of each pyramid. So we know, well, if it's a pyramid, volume is 1/3 area of base times height. So we just have to figure out how to get the area of that base. What are we going to use to get the area of that base?
1/2 base times height.
1/2 base times height of that triangle. So 1/2, what would we call the base of that triangle?
9.
9 and 5. Doesn't matter which one we call the base and which one the height of that triangle. So that's the area of the base right there, times the height of the pyramid. What's the height of the pyramid?
10.
10. Approximately.
75 inches.
Oh, it's exactly 75 inches cubed. Yes. You may hear in just a little bit. Number 2. You might have to just wait for your neighbors right now. Number 2. Volume. We know is 1/3 area of the base times height.
You got your wish. Yeah.
I got my wish. We're going to have to figure out the area of the base of the what? Of that pentagon down there. So when we write this one, we have 1/3 times, what's the formula for the area of that pentagon?
1/2 apothem times perimeter.
1/2 apothem times perimeter times the height. So it's going to be 1/3 times 1/2 times, do we know the apothem?
3.
3. Oh, they weren't so bad for us. They even told us what it was. Times perimeter?
22.
How'd you get 22?
4.4 times 5.
4.4 times 5, 22. Times the height of the pyramid? 12. Now what I'm going to do, 3 and 2 make 6, or you can do it this way. 3 and 3 cancel, 2 goes into 12 6 times. It's really just 6 times 22 is all that's left.
Yep.
132? What was our unit?
Centimeters.
Centimeters cubed. Or volume. Well, see, they have not been evil for us yet.
Yeah.
Number 3, a rectangular pyramid happens to have a height of 5.2 meters and a base of 8 meters by 4.5 meters. Okay, well, we know volume equals 1/3 area of base times height. 1/3 times, how are we going to get that base? Area of the base. We need the area of that base. Can you tell me the numbers? 8
Times 4.5.
times 4.5. I said the base was 8 meters by 4.5 meters. And what's the height of it? 5.2 meters tall. Which equals 62.4 meters cubed. And please write down how these answers come, not a set of numbers that are answers. That tells a teacher that you're just copying answers from somewhere, whether you are or not. Number 4, a square pyramid happens to height of 14 meters as a base with 8 meter side length. Well, volume, 1/3 area of base times height. So 1/3, how are we going to get the base?
8 times 8.
8 times 8. What's the height?
14.
14.
Volume equals 298.7.
298.7 inches cubed. Why didn't we do 8 times 4? What would 8 times 4 be? Is that your question? 8 times 4 is the what of the base?
The radius.
It's the perimeter of the base. If you did 8 times 4, you would just have told the perimeter. We're not interested in the perimeter, we're interested in the area. 8 times 8, area of the base. Number 5. Volume. Okay, they're cones, so we know volume is 1/3 pi r squared times height. So 1/3 times pi radius?
3.5.
3.5. That has to be squared. Height? 14? 4.
Volume equals 51.3.
51.3 inches cubed. Approximately. Number 6. Cone again. Volume equals 1/3 pi r squared. So 1/3 times pi, we just need to know the radius so we can, oops, times height. Times height. We just need to know the radius down here. Do we know the radius?
No, we need to use tangent.
Yeah, we've got a right triangle. I'll kind of draw it out here to the side. That's the radius. There's the height. It's 90 degrees. There's our coming up the side of it. They said it's 18 degrees right up here. And coming up the height is 11.5. 11.5, so we just need to figure out the radius down here. Tangent of 18 would equal what over what?
X over 11.5.
R over the 11.5. The radius over 11.5. Opposite over adjacent. So I can just multiply by 11.5.
3.7366.
3.737 if I was going to round. Now here's what I'd do if I were you. I'd take that answer, 3.737, whatever it is. I would square it in the calculator. I'd multiply it by the height, which is 11.5 times the pi. Then I'd divide that answer by 3 or multiply by 1/3. Your preference. 168.1 is the answer you should be getting. So try to avoid rounding until that final answer. That's why leaving it in your calculator, I guess it wasn't in inches, was it? Leaving it in your calculator is the good thing to do. Then you get exactly the answer, hopefully, that the book has. Number 7, an oblique cone. What does that mean?
It just means it's kind of tilted.
Yeah, this means it's kind of tilted. Do we care that it's an oblique cone with our formula?
No.
We don't. So the same formula equals 1/3 pi r squared times height. 1/3 times pi. Do we know the radius?
Yep.
Yeah.
1.6.
1.6. That has to be squared. Height?
14.
14?
No, sorry, 10.5. Things.
10.5. A little bit different than 14.
28.1.
28.1 millimeters cubed is what you should be getting. 8.1. Number 8, a cone with a slant height. We'll draw a little picture real quick. Here's my cone. The height of my cone would be that thing right over there. Where's the slant height of the cone go in the picture?
This side.
The side. Slant height is the side. So they said a cone with a slant height of 25 meters. So that diagram really helps me. I have a slant height of 25. Happens to have a radius of 15 down here. I know my volume formula is still 1/3 pi r squared times height. The thing we don't know is our height. How do we get it?
25 squared minus 15.
Pythagorean theorem would work. Is this a Pythagorean triple?
Yeah.
Which one?
3, 4, 5.
So 3, 4, 5. 3 times 5 is 15. 4 times 5 is 20. 5 times 5 is 25. This thing is just a 3, 4, 5 triangle 20. Pythagorean theorem would work. 1/3 times pi. Our radius was 15. Has to be squared. Our height is 20. Approximately.
100.
How much?
471.2.
Are you getting 471.2? I mean, my book says something different, but anybody else?
Oh, 471.
471.3? 0.2?
What did you, is the book saying 4,000?
My book says 4,000.
Yeah, sorry, I did it wrong. That was 4,000.
4,712.4.
4,000.
4,712.4. A little different than 400 meters cubed. Those pesky dots for decimal places. Number 9, going to museum, the Sky Dome of the National Corvette Museum, Bowling Green, Kentucky. Hey, you know what happened to that thing a couple years ago? Sinkhole. Dropped all these Corvettes down into a hole and crushed them. But anyway, if the height is 100 feet And the area of the base is about 15,400 square feet. Find the volume of the air that the heating and cooling system would have to accommodate, round to the nearest 10. Now, they weren't real clear. In fact, they were a little misleading. What did they say this thing was?
A dome.
They said a dome, but I don't think they mean that. Because a dome is what shape? Yeah, semi-sphere, right. A dome, that's not what we're dealing with in this chapter. So what do you think they really meant? Cone. That's what they meant. Does it say that? Oh, mine doesn't say that. Oh, well, your book is different than mine. That would be very helpful. All right, so there we go. Height is 100 feet, so we know our height, 100 feet.
Oh, it tells us the area.
And area of the base is 15,400. Well, are we in feet? Is that what we're doing? Yeah, we're in feet. So in other words, they have told us everything we need. We know the volume is 1/3 pi r squared times height. 1/3 times pi. Maybe we don't know everything we need. Do we need that or do we not?
You don't need pi, do we?
Do we?
There.
Ah, they told us the area of the base. So in place of pi r squared, we simply put 15,400.
Yeah.
And the height is 100. So how much air do they have to heat and cool in that thing? A little more specifically.
513,333.3.
There you go. That's how much air they're going to have to heat and cool in their building. Exactly. Who cares about the air? How about working on the floor?
I think it's 6 foot.
I don't know, like about 20 feet across, wasn't it? It was big. Enough to drop a bunch of cars in it.
I mean, we can calculate that. We can calculate real quick before we move on. If we calculate the radius, then we can figure out the diameter. Then we can know how much of a portion that this thing will take out. Therefore, take up time. If you want to.